Acoustic location was used from the middle of World War I until the beginning of World War II for the passive detection of aircraft by picking up the noise of their engines. Passive acoustic location works by detecting the sound or vibration produced by an object and then analyzing that data to determine the object's position. The horns provided both acoustic amplification and directionality. The greater distance between the horns compared to human ears improved the observer's ability to pinpoint the direction of the sound. One advantage of acoustic methods was the ability to see around corners and over hills thanks to sound refraction. This technology became obsolete before and during World War II with the advent of radar, which proved far more effective. The first person to use such equipment was Commander Alfred Rawlinson of the Royal Naval Volunteer Reserve, who in the fall of 1916 commanded a mobile anti-aircraft battery on England's east coast. He needed a way to detect Zeppelins in cloudy weather, and he improvised a device using a pair of gramophone horns mounted on a rotating pole. Some of these devices could determine the approach of airships with surprising accuracy, allowing guns to be aimed at them even when the targets were out of sight. Although this method never resulted in a confirmed hit, Rawlinson claimed that on occasion he forced Zeppelin to drop its bombs prematurely. Anti-aircraft acoustic devices typically consisted of large horns or microphones connected to the operator's ears through tubes, resembling an enormous stethoscope. Most of the work on determining the range of aerial targets was carried out by the British, who developed an extensive network of sound mirrors used from World War I through World War II. Sound mirrors usually operated with movable microphones that could be adjusted until they received the maximum sound amplitude. The angle at which this occurred indicated the direction of the target. Two sound mirrors placed at different locations produced two separate bearings, allowing triangulation to determine the source of the sound. As World War II approached, radar emerged as a reliable alternative to acoustic aircraft detection. Britain did not publicly acknowledge the use of radar until the start of the war. Instead, as in the United States, acoustic detection systems were widely deployed. It has been suggested that the Germans were wary of acoustic detection and that this was why the engines on their heavy bombers often ran unsynchronized, contrary to the usual practice of synchronizing engines to reduce vibration in hopes of making detection more difficult. Given the typical aircraft speeds of that era, acoustic detection provided only a few minutes of warning. Acoustic listening stations remained operational as a backup to radar, as demonstrated during the Battle of Britain. After World War II, acoustic location lost its role in air defense operations.